Okay, I want to expand a little bit on determining the domain of a composite function. And what you have to realize is that when we take f of g of x, the g of x has to have certain restrictions. All right, the embedded function will always have to have the certain restrictions. And in the case of the example that we did, we had the square root of x was a second function, and we knew that our domain was x had to be greater than or equal to 0. The other thing that we have to realize is that if f has its own domain restrictions, we need to set this equation not equal to those restrictions. In the last example that we did, I want to say we had something over x. Let me get it. We had 1 over x minus 1. Okay, oops. And in the end, our domain was x greater than or equal to 0, x cannot equal 1. The reason that x could not equal 1 didn't have anything to do with the fact that the original domain of f was that x could not equal 1. Okay, you have to understand that. I just happened to use numbers that worked out kind of fluky and only because the square root of 1 is 1. So I'm going to do another example real quick here that's more complicated. I'm going to have f of x equals x plus 2 over x squared minus 7x plus 12. G of x is equal to the square root of x minus 2. Okay, and I'm going to do f of g. And I want you to understand that finding the domain of f of g is going to be a lot easier if you follow what I'm saying on here. Okay, originally our domain on f of x is that, let's try that again. Our domain for g is that x has to be greater than or equal to 2. That domain will always be part of our final domain for the composite function. But I want you to understand that our domain here, if you factor out the denominator, yeah, I said factor out the denominator, you'd have x minus 3, x minus 4. Okay, the domain of that function obviously is x. Why can't I get these stupid points there? X cannot equal 3 or 4. So when you're coming up with a composite function, you're going to take g of x cannot equal 3 or 4. Because if g of x equals 3 and you plug it into f of x, you're going to get a 0 in the denominator. All right, so that means we have to take the square root of x minus 2 cannot equal 3, and the square root of x minus 2 cannot equal 4. Square and add, we have x cannot equal 11. Square and add, we have x cannot equal 18. All right, so our final domain is going to be all three of those pieces, this, and that. Okay, now I want to emphasize that once you get this, that you take this and you set it not equal to that. Because the composite function that you get when you calculate f of g sometimes is going to be a lot more complicated than just saying that square root of x minus 2 cannot equal 3 and 4. Okay, if I were to calculate the composite function, in this particular case it is rather nasty because f of g is actually equal to the square root of x minus 2 plus 2 over x minus 2 minus 7 square root of x minus 2 plus 12. So I ask you, would you rather take this and set it not equal to 3 and 4 at the beginning, or would you rather take this whole thing, x minus 2 minus 7 square root of x minus 2 plus 12, and set that not equal to 0 and figure that out? This is the way to go. All right, so take your embedded function and set it not equal to, the things that are restricted in your domain for the f function. And I hope that clears everything up nicely for you. Adios.